Hello everyone, welcome to Science Now.
Hey there, science fans! Today we're diving into the fascinating world of eddy currents. These invisible forces are at work all around us, silently shaping our technological world. Eddy currents are essentially swirling loops of electrical current. Imagine a calm pool of water. Now drop a pebble into it. What happens? Ripples, right? Eddy currents are kind of like those ripples, but instead of water, they flow in conductors like copper or aluminium when a magnetic field nearby changes. These currents are named eddy currents because they flow in closed loops, much like eddies in rivers or streams. They might be invisible, but don't let that fool you. Their effects are anything but. So buckle up as we journey into the heart of eddy currents and uncover the secrets behind their incredible power. So, how do these mysterious eddy currents come to life? The answer lies in a phenomenon called electromagnetic induction. Imagine a magnet approaching a conductor like a copper sheet. The moving magnet causes the magnetic field around the conductor to change. This change in magnetic field does something really cool. It induces or creates a voltage difference within the conductor. This voltage difference is called electromotive force, or EMF. Think of it like an electrical pressure that pushes electrons around. This push, generated by the changing magnetic field, sets those electrons in motion, forming our swirling eddy currents. The faster the magnetic field changes, the stronger the EMF and the more powerful the eddy currents. It's like riding a bike. The faster you pedal, the stronger the wind you feel. Now that we know how they are born, let's see what these swirling currents can do. Hold on tight, because eddy currents pack a punch. They may be invisible, but their effects are anything but subtle. One of the most important effects of eddy currents is magnetic damping. Imagine a swinging pendulum. Normally it would swing for a long time before slowly coming to a stop due to air resistance. But if we place a strong magnet nearby, something fascinating happens. The swinging pendulum slows down much faster. Why? Eddy currents. As the pendulum swings through the magnetic field, it induces eddy currents in the magnet or a nearby conductor. These eddy currents, in turn, create their own magnetic fields that oppose the pendulum's motion, acting like a brake and bringing it to rest more quickly. But wait, there's more. Eddy currents also generate heat. Remember the copper sheet and the moving magnet? Well, the resistance encountered by those swirling electrons within the copper generates heat, just like an electric heater. This heating effect has some really cool applications, but more on that later. Eddy currents aren't just a scientific curiosity, they are the unsung heroes of countless technologies we use every day. Ever wondered how metal detectors work? They use eddy currents to sniff out hidden treasures. When you sweep a metal detector over the ground, the changing magnetic field from the detector induces eddy currents in any metallic objects buried beneath. These eddy currents then create their own magnetic fields, which the detector picks up, alerting you to the presence of metal. Pretty neat, right? Eddy currents also play a crucial role in modern braking systems, especially in high-speed trains and roller coasters. These systems use electromagnets to induce eddy currents in the rails or tracks, creating a powerful braking force without any physical contact or wear and tear. Talk about a smooth stop, but that's not all. If you have an induction cooktop, you can thank eddy currents for your next meal. These cooktops use rapidly changing magnetic fields to induce eddy currents directly in your pots and pans. These currents generate heat, cooking your food with incredible speed and efficiency. From detecting hidden treasures to cooking our food, eddy currents are truly the hidden force shaping our technological world. So next time you encounter a metal detector, a high-speed train, or an induction cooktop, take a moment to appreciate the silent power of eddy currents at work.